Hello, I'm Jae-Yoon Jung, a postdoc in Edge Lab at Princeton University. In this video, I will introduce a research project called Spread Storage. Spread Storage is a way to realize elasticity of distributed storage resources in cloud-to-things continuum. Fog computing and dispersed computing are emerging technologies that leverage the proliferation of internet-connected edge devices to enable next-generation applications. These devices, such as smartphones, tablets, or set-top boxes, are not only increasing in number but also gaining more CPU and storage capabilities. The resources are continuously distributed on the continuous space called cloud-to-things continuum. However, today's applications are not generally distributed. They are usually relying on cloud. Even though cloud realizes dynamic resource allocation and scaling on top of virtualization and resource management platform, users are still relying on the single service provider without any controllability or manageability. In this research, we propose a practical and efficient way to integrate distributed edge and cloud storage resources at client while considering scalability, availability, and privacy protection. Shroud and Spread is a middleware between file system on client and remote storage services. It maps data in legacy file system into multiple storages with file chunking for client-side data deduplication and data encoding for high availability and privacy protection. A file is sliced into smaller pieces to reduce amount of data stored by finding duplicated pieces. Each piece is encoded into N shells using erasure code or secret sharing algorithm. To access the data, enlist T from N shells are required. It means a single storage service provider cannot read user data. In addition, at most N-T storage node failures are acceptable. We designed and implemented Shred and Spread storage for Linux and Mac operating system. We implemented a virtual file system by implementing most POSIX interfaces using Fuse library. We extended file handler that contains where the actual data is stored and redirects file I/O operations to the remote storages. The virtual file system accepts the same file I/O that native operating system supports while encoding data and spreading them into edge and cloud storages in the middle. Currently, the prototype supports, but not limited to Amazon S3, Dropbox, and FTP storage. We can easily implement a storage adapter with about 100 lines of code. Now, we are going to show demo of our prototype implementation. We developed the GUI interface to authenticate multiple services. Our prototype has an in-app file browser, but it actually mounts multiple storages directly into a local mounting point. It looks exactly the same as an external drive. The mounting point provides the same file I/O interfaces, so users can drag and drop files or even directly read and write files on the Shred and Spread storage. When a user reads or writes files, they are automatically downloaded and uploaded into multiple storage services in form of encoded chunk. If a user opens a file, our prototype collects required pieces and reconstructs the original file. The data stored in each storage is scrambled, so it is not readable at all. The user only knows how to reconstruct the file by combining data from multiple storage services. We also decouple metadata information from data files. The metadata contains which pieces are required and where the pieces are stored. Thank you.